In section 7E, what we'll do is learn some counting techniques. So there are some easy ways of doing efficient counting. And why do we need counting rules? So we can find probabilities of certain events that require counting. The most basic rule of counting is the fundamental counting principle. If a certain task can be completed in m ways, another task can be completed in n ways, then the total number of ways in which we can complete the task is m times n. Now, suppose we have 3 cars to choose from, 3 types of cars, or 3 models, if you want to call it a model. And we also have 2 colors to choose from. So in order to make a selection of a car, we need to choose the type of the car and also the color. Now, how many different choices can we make? So let's say the 3 colors are red, blue, and green. The 2 colors are red and blue, and the 3 cars are maybe Honda, Toyota, and I don't know, something else, Ford. So what are the types of cars that we can buy? We could buy a Honda in red, a Honda in blue, a Toyota in red, a Toyota in blue, a Ford in red, and a Ford in blue. So what are the total number of choices? We have 1, 2, 3, 4, 5, 6 choices. So 6 possible choices of cars. Now it's not a coincidence that there are 3 choices of cars, and so and goes with times, 2 colors to choose from, so 3 times 2 is 6. So this is the fundamental counting principle. Now it can be extended to more than 2 tasks. So what were the 2 tasks in this example? Choosing a car and choosing a color. So if we complete these 2 tasks, then we have made a choice of a car. So how many different choices do we have? 3 times 2 equals 6. Now, we can extend the fundamental principle of counting by maybe looking at 3 tasks, 4 tasks, or in general, k tasks. And if we know the number of ways in which to perform each type of task, then all the tasks can be performed together in the product of the numbers. So n1 times n2 times n3 and so on up to nk. Now, the fundamental principle of counting can be used to figure out many other techniques of counting. So let's look at this first example. It says use the counting principle to find the total number of ways of arranging 3 letters A, B, C. Now, let's just crudely arrange the 3 letters in different ways. So we have ABC, ACB, BAC, CBA, and so on. So we've exhausted all the possibilities. Now, if you think about it, arranging 3 distinct or different letters in 3 different ways amounts to filling 3 blanks with the letters A, B, and C, making sure that there are no repetitions. So arrangements of letters is the same as filling blanks with different letters, making sure there are no repetitions. So we have 3 blanks to fill: the first blank, the second blank, and the third blank. So we'll go step by step. Let's look at the first blank. How many different ways can the first blank be filled? It can be filled in 3 different ways because we have a choice of 3 letters to fill the first blank. But once that is done, Now we filled the first blank, which means out of the three letters, we only have two left. So how many ways would we fill the second blank? We can fill the second blank only in two different ways because one letter is taken. One of the three letters, no matter which one it is taken. So we're left with 3 minus 1, two choices. Now, once we've filled the second blank with the third blank, we've already used two letters. What we are left with is just one letter, so we can only fill it in one way. Now, all three blanks are filled and our task is complete. So, how many ways can we fill all three blanks? The first blank can be filled in three ways, and the second blank can be filled in two ways, and the third blank can be filled in one way. The total number of ways of filling the blanks is 3 times 2 times 1, which is equal to 6. How do we get the times? By using the fundamental principle of counting. Let's look at part B. Now we have 5 letters, A, B, C, D, or let's say 4, I'm sorry. So these are 4 letters, A, B, C, D, and we want to arrange these letters taking only 3 at a time. So we're going to arrange uh, the letters A, B, C, and D, but not taking all of them at the same time, but taking only 3 at a time. So again, we have a task of filling 3 blanks. We start off with a full set of 4 letters. The number of ways of filling the first blank is 4. Once that is done, okay, one letter is taken. So now we have 4 minus 1, which is equal to 3 letters left, and 3 letters to fill the blank. So we fill the blank with 3 letters, with any one of the 3 letters. This can be done in 3 ways. Once that is done, we filled the second blank. Now we are left with 4 minus 2 letters, which is 2 letters. We can fill the third blank with 2 letters. And after filling the third blank, our task is complete. So the first blank can be filled in 4 ways, and the second blank can be filled in 3 ways, and the third blank can be filled in 2 ways. So the total number of ways of filling all 3 blanks is 24 ways. So the first counting technique that we've learned is called the fundamental principle of counting, or the fundamental counting principle. Uh, Using that principle, we're going to come up with other formulas that do different types of counting. And in order to use those formulas, we need to learn what is called the factorial notation. So 1 times 2 times 3 times 4. If we had to find this using a calculator, we'd enter it just the way we see it here and hit the enter button. However, we can also use what is called the factorial notation. So 4 factorial is the same as the product of all natural numbers starting with 1 and ending with 4. So we can use the factorial button and hit enter to find the product 1 through 4. Now, where exactly do we find the factorial button? So in a TI-83 calculator, look for the math button. Once you hit math, then select PRB. Once you hit PRB, you'll see a menu with 1, 2, 3, 4, 5, 6, 7. The fourth one contains the factorial notation. So if you want to figure out, for example, 7 factorial, enter 7 on the screen, go to math, probability, fourth option, which is factorial, select that, and you get 7 factorial on your screen. Hit the enter button, and you get whatever the answer is. Now, when it comes to some large factorials like 13 factorial, which is doable, but still it's kind of tedious to enter all these numbers into your calculator. You go 1 times 2 times 3 times 4 instead. We can just enter 13 and then the factorial the way I described it on the right here. So what is 9 factorial over 6 factorial? Can we use the definition of factorial to make our calculations easy? 9 factorial is the product of all natural numbers 1 through 9. 6 factorial is the product of all natural numbers 1 through 6. Cancel factors up to 6, and what we're left with is 7 times 8 times 9. So 7 times 8 times 9 is 504, and that is the product. So what about 400 factorial over 399 factorial? Now we can kind of do this in our heads. 400 factorial is every number, product of every number 1 through 400, divided by 399 is the product of all natural numbers 1 through 399. So every number up to 399 gets cancelled. The only number left is in the numerator, and that's equal to 400. You can check your answer using the factorial function on your calculator. So you go 400 on the screen, select factorial by going to math PRP divided by 399, and then select the factorial, and you're going to get the same answer, which is 400. Now, similarly, you'll notice that I've done each of these problems by first expanding the factorial, seeing what gets cancelled, and finally using the calculator on the leftover terms to figure out what the final answer is. In each case, do the problems by hand first and use the calculator only at the end, and then check your answer by using the factorial function on your calculator. So every problem is pretty much done the same way by using the definition of the factorial. So let's quickly look at this. 6 is 1 through 6, all numbers. 8 is 1 through 8, all numbers. 4 is 1 through 4, all numbers. And 5 is 1 through 5, all numbers. So when we cancel common terms, we are left with just the 5 times 6 and the 7 times 8 times 6, and that gives us the final answer, 10,080. One important thing to remember is that definition of 0 factorial. It almost seems like it should be 0, but it's not equal to 0. 0 factorial is equal to 1. Now we're going to see two more counting techniques. So our first one was the fundamental principle of counting, and we're going to see two more. The first one is called permutations. What are permutations? Permutations are arrangements of n distinct objects taking all n at a time. So if we have 5 or 4 distinct objects like we've seen before, A, B, C, and D, and E, we take all 5 and arrange them in different ways. So we go A, C, B, D, E, C, A, D, E, B, etc., etc., and then we count how many possible arrangements we can get. So instead of doing the counting in a crude way, we could use the formula, and part of which we've derived in the previous 3 pages that we've done. NPN means number of arrangements of n distinct objects taking all n at a time is equal to n times n minus 1 times n minus 2 dot 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 keeps going times 3 times 2 times 1. And that is the same as n factorial. If you read it backwards, it's 1 times 2 times 3 dot 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 n minus 2 n minus 1 n, and that is n factorial. So if you have a specific number of distinct objects, let's say 5 distinct objects, and you want to take all of them and arrange them in different ways, then you'll get 5 factorial arrangements. So arrangements of distinct objects uh, so you're never going to see repetitions because these are arrangements of n distinct objects taking all n at a time is given by n factorial. Now the formula for the number of arrangements of, let's say, 5 distinct objects taking only 3 at a time is given by 5, the total of 5. Permutations means arrangements taking 3 at a time. So you always take either the 5 or a number less than 5. And 5p3, this number on the left of p is n, which is the total number of numbers. And this number is called r. So if you plug in these numbers into the formula, you can get the value of the number of permutations of n distinct objects taking r at a time. We could use the formula, but when you're doing problems, make sure you use the calculator. It's much quicker. How do you use the calculator to figure out NCR? Go to Math, MTH button, then go to PRB. Use your cursor to shift that to the right to highlight PRB. And once you do that, you see a menu 1, 2, 3, 4, etc. And NPR is the second in the menu. So we have NPR right here, NPR, and we select that. Now, the next counting technique is selections or combinations. So the number of selections of 3 people from a group of 5, let's say, is written as 5C3. So from 5, choose 3, which has to be a smaller number. So NCR is the number of selections of R objects from a total of n objects, and this is the formula that is used. But I suggest in problems just use your calculator function, which is the NCR function. That is much quicker instead of entering all the factorials.